Hello, everyone, and welcome to my talk. So to start with, I would like to know, are there any Android developers here? Okay, so have you ever worked with Flutter before? Or, yeah, okay, so everyone has a bit of understanding of Flutter, right? Because this is a Flutter track, so probably it's best if you know at least basics of Flutter. So I am Alicja Ogonowska, and I'm from Poland. And I have over 6 years of experience with mobile app development. And I also have an Android background, but I switched to Flutter almost 3 years ago, and I've never regretted the change. So if you are still on the native side, then consider switching as well. And I work for a Polish company named Equico, and my current client is Flaconi, which is a German e-commerce beauty shop. You can find me on social media, on actually all of them, and usually I'm quite easy to find because I always use my name and surname as a handle. And I would like to start with thanking my colleague, Natalie Mas-Hooper, because she was the one who introduced the concept of full widget tree tests to me and my whole team at Flaconi. So without her, I wouldn't be here today. So make sure to also check her out because she also did an article covering this topic. And today, I would like to tell you some basic stuff about software testing. Finally, I will tell you what a full widget tree testing is, so don't worry, we'll get to that. I will tell you about the advantages and disadvantages of it, how you can get started. There will be also a full example, so I will be showing quite a lot of code, but you don't have to pay that much attention to the code itself rather than to the things that I will be saying, because at the end I will show with you the source code. And later I'll cover the common problems that you may encounter, because of course I've already been there and maybe I can make it easier for you in the future, and then I will wrap it up. So I'm sure we have all professionals here and you all know why we need tests. Of course, we need tests to sleep better at night, and John surely can agree with me. But honestly, when you have a big suite of tests, you can make sure that your code actually works. And it doesn't only work in the happy paths, but you are also prepared for errors and edge case scenarios. And also, it will allow you to catch your regressions issue earlier, because if the test fails, then either there has been a change in the code or a change in requirements. But anyway, you have to work on that. Also, it will give you more confidence when you are trying to refactor, because with a big amount of tests, you will be informed if something breaks. And also, you have a living documentation, and you don't have to wonder, am I covering such a case? You can just check your test suits and check if such a case is tested and covered. And also, you can quickly verify your architectural decision, because if you think writing tests is too complicated, then probably you did something wrong beforehand. In my career, I have heard this sentence, unfortunately, quite many times. We don't have time and budget to write tests. And each time I thought, okay, that must mean you must have an enormous budget to fix bugs on production, because honestly, this is what it usually looks like once the feature and product is actually shipped to the users. There's even a cool chart done by the IBM, which shows you the cost of fixing defects at a given stage of development. And as you can see, it's quite clear. Once the product is shipped to production, it's really costly to try to fix it. So really, it's better to invest your time at the design and implementation phase, even if your clients say that they don't have money for that. It is your job to convince them that it's better to invest it at an early stage of product development. And when it comes to Flutter, automated testing falls into one of a few categories. We have unit tests that test one method or a class. Widget tests, which are also called component tests, which lets you test a single widget. And there are also integration tests that run on a device or an emulator and lets you test a complete app, or at least a large portion of it. And does any one of you have any experience with writing integration tests? Okay, that's great. And today I won't be talking about integration tests, so hopefully everyone will get to know something new. We want the tests that will be easy to write, give you confidence, and are cheap. But unfortunately, you can roughly choose just the two of those. And each kind of those tests have its own limitations and problems. So you can easily write unit tests, but they just test a small portion of your application. You can write integration tests that test whole flows, but then you have to invest more time and money to maintain them. And this is where widget tests are coming in handy, because this is something that is really Flutter specific. And it allows you to write, to test your widgets. But in Flutter, I think you've heard this catchphrase, everything is a widget. So you can test for a list item in your list of elements. You can test your whole list with many elements. You can even test your screen that displays this list. So why not go one step further and test for the whole app? And this is exactly what full widget tree testing is all about. So instead of testing widgets in isolation, you each time test for the whole application and recreate the path that a user would have to go to encounter a given widget. So for example, if you want to test your login screen, you don't pump the login screen, you just pump the whole app and navigate through your menu or tabs, whatever your application is doing. And this is just as the user would do. So when you compare it with other kinds of tests, with full widget tree testing, you get confidence as high as integration tests, because we are able to test everything up till the network layer. So this is what is not actually done, because we mock the responses. But on the other hand, it's easy to also mock some error responses or even timeouts. While in integration testing, yeah, it's not so easy. I've heard about some APIs that if you send a request with a given parameter, then you will get a given response error code. But yeah, I'm not sure if this is something you would like to have in your API live. When it comes to maintenance cost, of course, this is higher than unit test, but I would say it is just as high as widget testing. And once you are familiar with plain widget testing and do the setup, everything starting from then is not that difficult. Of course, when it comes to dependencies, there is quite a lot to mock, as you have to be able to run your whole app, but it will pay off in the future. And the good thing is that it's really quick. So if you've ever run your integration testing and were waiting for results and that then got an error and had to start debugging where's the problem, then you will probably appreciate the fact that with widget testing, this is really quick and really speeds up the whole process. So there are many pros of full tree widget tests. Otherwise, I wouldn't be giving a talk about it. First of all, they are really quick to run, and then you don't have to wonder, okay, so I have to build my whole application each time. Yes, because it doesn't cost that much, and then you can recreate it each time. And it also allows you to write smaller tests, because each test can test for a different scenario, and you don't have to go back if it's not the thing that you want to test. You can also spot mistakes happening between widgets, because it's very nice to know that widget A and widget B are working correctly, but it's also super good to know that they are actually, you are able to navigate from one to each other and go back, and that they cooperate as they should. And also, yeah, it's very easy to mock every kind of response, because you have whole control over the responses that your API would produce. And also, you can quickly get high test coverage. And I'm not saying that this is something you should totally aim for and only focus on the number, but it can be quite useful if you start with a low-code coverage. And for example, you plan a big refactor, then this kind of tests is really useful, because if you first cover your application, then you can really recover with confidence. And I'm saying this from my professional experience. And also, yeah, it's a lifesaver during a refactor. Yeah, it also works as an acceptance criteria because you have tests. If you write proper testing names, then you know exactly what cases are covered. And also you get to test almost your whole application. As I said, only the API responses is the moment where we start mocking. Of course, if you are using some third parties or some native plugins, you can also mock them as well. And it's also easy to test for different screen sizes and plug it in your CI and have a really big amount of tests covering many scenarios. And after the setup is done, because yeah, this is maybe the most difficult part, then it doesn't differ that much from the testing for plain widgets. Of course, the world is not perfect, so there are some disadvantages, and the setup might be a bit tedious, but I will show you everything. And maybe it was tedious for me when I didn't have that many examples to look at, and after this talk, it will be much easier for you. Also, if your API responses are quite complex, it can also become hard to maintain those responses. But I'll also show you a resolution for that. And also we test for what the user is seeing on the screen, but we are not actually seeing it. So sometimes it may be tricky to know what is actually happening in those tests. Yeah, it's not so obvious why a test is failing. So in the end, I will give you some tips and tricks how to debug them. And it's a wild west out there because this topic is not that popular. So maybe after this presentation, it will change. So if you are asking yourself, what can I do? I want to start. I want to try it out. Of course, you need to start with a setup. But first of all, I would recommend you to write the simplest test for your main screen. So something that is simple enough to make sure that you have your setup running and you don't waste too much time mocking all the complex network responses. Then you can prepare and register all your dependencies. So as you will be trying to run those tests, you will know what is actually missing. And then at the end, you can go to the network layer and mock the responses. And for the purpose of this talk, I prepared a very simple app. So it uses Go REST API because I wanted to use an existing API. I didn't want to write my own, waste a lot of time and probably doing it poorly. So I found an API that is actually free, and it allows you also for adding content. So the business logic of this API is about posts and users, so consider it as a very, very simple social media application. So basically, the user can see a list of posts, and they also can log into their account, and once they are logged in, they are able to add their own posts. And one disclaimer, because this API doesn't really support account creation, then you have to, so basically in the app, if you'll be checking the code, you will find out that actually the whole login is just inside the application and it's mocked also in the app. So I hope Majid is not here because he said that we shouldn't rely on authentication on the device, and this is exactly what I did, but this is only because I didn't want to get too complex. And as I said, once the user is logged in, they get the plus button and they are able to add a new post. If they don't have a connection, as I turned off my Wi-Fi, they get an error. Once the connection is back, they will see a success message. And if they come back to the page, it is actually added. And I think other people who are also using this API may also see it. So this is just for a presentation purpose. And also I added like an error screen if during launching the app there is a problem, no connection, then the user sees this error and then can retry. And this is how the code structure looks like. So it will give you an overview of what I'll have to mock in order to get the app running. So as I promised, we will start with the simplest screen. So on my post screen, I would like to see an error message when a request fails. So for now, I won't be mocking the API part. So this is what I expect. API call will fail as it is not handled by the app. I will see the error. And for that, I need to get my main screen widget. Then, yeah, I will launch the post tab. And then I'm trying to look for the text, oops, something went wrong. And one thing that I do while writing such tests, I try to write them from the user's perspective. So I don't test for widget types or even widget keys, but mainly test for what the users can actually see. Because the user doesn't know whether the text has key error message or something else. They need to see the error. And the other thing, yeah. So basically, to see the main screen, I will just have to create the app. And this is in my code. This is exactly what I put in the run app method. If you have something more happening beforehand, then you will also have to prepare it here. For example, in the Flaconi app, before running the app, we are setting up the localizations. And for example, for tests, we use English, even though the production app doesn't offer English to the clients. So this is just something for our convenience. And there are also some useful utility methods. I won't be showing everything on the slides. You can check the code later. But yeah, whatever works for you to make it more readable. Okay, so now that the basic setup is done, let's try and run it. And of course, it would be too beautiful if that would success in the beginning. Of course, I didn't mock any of my dependencies. And for this project, I'm using getIt, so I will need to register my dependencies. So back to the part where I am preparing the main screen. I'll do the configuration, and I'll go from the bottom. So as I showed you the code, I'm using use cases that need a repository. Of course, we need to go deeper with that mocking. Then we need the data source, and as we will be anyway mocking the responses, yeah, this is something that is needed for the Open API to work. So I don't need any API key. I don't need the URL. It will be anyway mocked. So, but I'm not using a mocked data source because I'm not mocking the data source. I'll be mocking the API. And then there is also like a logger that I'm using for some logging. And app HTTP client is what we'll be most interested about. So in the application, I'm using Dio, and app HTTP client is just a simple wrapper around it. So I will have to mock it. And for that, I will need to mock two methods that I'm using in the app, so only get and post. And I would like to return some mocked responses. If you are using more methods, then of course you also have to mock them. And for that, I'll prepare a mock server response manager where I'll be handling all my server mocks. And I can't just mock a response and return it every time because I will have different API calls. So I want to be able to mock it for a given URL. And for now, I'll keep it simple, and I will just return a 500 response each time. And this will surely allow us for the first test to start passing. And let's check. The first test is passing. And the second one is complaining about a dependency already registered because I didn't do any cleanup. So I also need to reset my dependencies. And after that, we can try again. And we also get an error, but this one is more expected because we didn't get the title. And in order to get the title of the main screen, we actually need to get the response for the API. So we can't live without mocking it till now. So some simple classes that will be useful for mocking it. It will be an API call protocol. And as I said, I'll be just using get and post. I will have two API calls in my app. So one will be to get the list of all posts and also to add a post. And I'll only have one API service that will be handling them. But you can imagine that in a bigger app, those classes, those enums will be much bigger, and you'll have much more to mock. And also I will define some response types that I want to handle. Surely you should aim for mocking them all. I will keep it simple. And when it comes to the mock server response, it should contain a type, so a code, an error message, if it will be an error message, error response, and also I will be returning the path to a JSON where I will store the successful response. Now I would like to identify the API calls because, as I said, there will be, okay, in this case just two, but I need to know which one actually are they. And as I said, there will be only one API service, which will be my post data source. And for that, the easiest option to actually identify the API service is use the name of this class as an URL. So I will go back to where I was registering the data source, and I will change my fake URL to something that is actually representing this exact API service. Now back to the manager. Just before we were returning a 500 response for each call, but I want to be able to decide which kind of response I want to get. And for each API call, I would like to be able to get a different response. So what does that sound like to you? You don't have to answer. I would say that it's a map. So I'll have a map where I will store the API calls and corresponding responses. And then I'm creating a method where I'll be just assigning for a given API call a response that I will be preparing. And then I need to be able to actually mock it. So this is what the app HTTP client will be calling. So first of all, when I will have a API call, I would like to know what kind of API service this is. And this info I will get from the URL. Of course, if it's not found, I will just print and throw so that I will be informed that I need to do some more mocking. Then I will check which kind of API service it is. Then I will identify which exactly API call it is. So in here, I will just have the get, but of course, I would also need to handle the post. And if you have a bigger project with many API services, many calls, then you just have to find a way to identify each one of them. So sometimes you will also need to get a bit more complex and, for example, identify the calls based on the parameters or some other data. And then I'll be creating the actual mock response. So first, I'm checking if my map contains this API call. Do I have a response mocked for it? If no, then of course print and throw. And if yes, I want to grab it and execute it. And when it comes to execution, if it's a response type of timeout, I'll just throw and I'm done for now. But if it's something different, then I still have to handle it and create a body for it. I'll get back to it, get the response code, and also add the request options. And in my case, I'm using DIO. So DIO automatically converts the received data to JSON. So I also need to do that because my app is expecting this. And if it's a successful response, then I'll just return the response. And if not, then I will throw a DIO error. And when it comes to creating body, I went with storing the data in the response in JSON files because this was the most convenient thing for me. So you can have different files for different kind of responses. For example, if you want a list, you can return an empty list, a list with one element, a list with 100,000 billion elements, and see how your app reacts to that. And if you should return the response, then this is just a JSON decoder. I won't be going that deep into that. And this is what we will be returning. And if this is an error message, then we have to prepare an error. I won't be handling such a case where you get 200 and an error is inside. If you have such a project, then I will pray for you in the evening. Okay, looks like the setup is done. We can add in this test that we'll be testing for the title above the posts list. We'll add the mocking. I have the JSON file with the response. I've actually taken it from the real API just to make sure that it's in the right format, but then you can just create it from scratch if this is what you need. And those two tests have passed. So we can say that the setup is more or less done. I don't know, was it painful? Was it not painful? You will see when you try it yourself. And from now on, you can just have fun and write different tests. So for example, I want to test for that case when there is no connection or there is a problem at the beginning and the user sees an error message, but they have also an option to retry. So what I will do is, at first, I will just launch the screen and find the error widget, because this is what I expect. I'm not mocking the API call yet, so it should fail. And then I will mock the response, hit the retry button, and at this point, I would expect it to actually return the posts list. But there is a surprise. It failed, and it failed not by not seeing the post list, so probably our mocking of the API is fine. It failed even earlier, so it didn't even find the error. And this is because I didn't clear the map of the responses, and it's still there. So just remember to always prepare all your data from scratch, and also I need to clear the mocked responses. Now I would like to test for a different case. So as I said, if the user is logged in, they will see the add the post button and they are able to add their own posts. So this is where we introduce like a starting condition, because once the user is logged in the application and they will kill it and open it again, they will stay unlocked. So I will add one more parameter to launching my main screen so that I want the user to be logged in from the beginning. And for that, yeah, I need to add some additional setup, and yeah, I don't see Majid here, so yeah, basically logging in my application is just storing any valid email and 6 characters as a password, and then you are all logged in. So this is all you need. Don't do that in your production applications. Yeah, right now after that, you can also test for the login screen. And in here, we would like to actually enter the text. Surely you already know that from writing plain widget tests. But yeah, I would like to find the title, which is above the screen. And then I would like to enter my text to form fields. And there are many different methods of how you can find a given element. I'll show it to you in a moment. And what is nice with this kind of tests is you get to write all kinds of wrapper functions that are just useful for you, because when I want to enter the text, I'm just interested in what kind of text I want to enter and where, and I don't want to care in my test code that I also need to pump something, blah, blah, blah. It all gets super long, so I like to extract such things to methods, but just use whatever works for you. And for finding this form field, there are many different approaches. So one approach I did here is I found the form field by a hint, because as I said, I don't want to look for them by the key. But you can also do it, for example, by looking for the title and then finding the whole column with the title and the text field. And yeah, right now there are also quite many new different testing frameworks. So for example, recently a thing named Patrol was released, and they also provide their own custom finders, which make it more easy. You don't have to write all those long finders, and you can just use something that was already written by someone else. And it was a really simple test. I wanted to enter the text to 2 fields and then click on login, but the login button was not found. And actually, there is a cool thing that I hope all of you know, and it's called debug dump up, which actually prints the whole widget tree representation to your console. And if you do that, you can check why is the login button not found. And as I was searching, I could see the login image, the login form, and also there is this login button, there is this text, but the test is not passing. So it would be sometimes really useful to be able to see what is actually on the screen. And the funny thing is that you can actually run your widget tests on your device. And you have to just do flutter run and specify the path to your test file. And after that, it actually launches on your device. And as you will see, yeah, the app launched looked really bad, like really bad. And as you can see, it has some strange sizes, and the login button is not visible at all. So of course, what you could do is scroll down to it, and this kind of method can be really useful in many cases if you have longer screens and the user also needs to scroll down. But in this case, come on, this was a really simple login form, and the button anyway should be visible. But as you could have noticed, the screen size was quite weird. And thankfully, you are able to set the screen size for your tests, and you can just put something that more resembles a modern mobile phone. And you just have to do that before pumping your main widget. And after that, I will run it again, and right now it looks much better. The error in the beginning is because I didn't mock the API call, because I'm not testing for this screen, so all looked good. And if you do that, you will have to put your JSON file path to the assets in pubspec YAML, because otherwise it won't be able to run on your device. So just remember to do it only for tests and remove it afterwards, because otherwise it will be shipped with your build. And one more bad thing is that running the tests on device interfere with network images. So if you use network images, then you can just forget about running the tests on your device. Sorry for giving you hope. Surely everything can be done, and probably there's a workaround for that, but I haven't digged that deep inside that. But yeah, you can do. And as you could see, probably there will be some problems that you can encounter during writing such a test. And the most common one, from my experience, is when a view should be there, but the finder can't find it. And it can be actually really frustrating to find out what is happening if you don't get this preview on the device. So the first one that you should do is go with the debug dump up and start debugging. And also make sure that you are actually on the right screen, because in my case, in most situations like that, I was thinking I am on one screen, but I was, for example, still on the previous one because, I don't know, a tab didn't work and I didn't navigate to the next thing. And also, important thing, if you are using finders, just remember that you have to actually check for how many times the element was found, because just using find text widget, which is just finding the text, will always pass, and it will give you like false positive results, because as I said, you will be writing your tests, you will check, okay, yeah, login to your account passes, so I am on the login screen, and then you will try to do something else, and it fails, and then you realize 2 days later that you were all the time on the first screen of your app because you never really navigated to login screen. So this should have the dot once or times, depends. And also, if you are using a block, you can use the block overrides to actually log your block events in the test. So it can also give you a bit more information of your current app state. Sometimes you will need to scroll down the view because, as I said, in bigger screens this is necessary. And also, sometimes when you are looking for a text, make sure that maybe the text is there, but it's overflown with ellipses and it's not fully visible. So in such cases, it may be useful to check if a widget contains a text and not check for a specific test. And also sometimes you need to be like Denzel and pump it up, and because maybe there is some asynchronous work going on and animation that you have to wait for, and you just have to be a bit patient. A different situation, yeah, a view should not be there, but the tester finds it. So it's quite similar to the first one, and all the solutions also apply to it. So just debug it and make sure that you are on the right screen. Also be careful with widgets like opacity or expandable widgets, because you may expect them to be not visible, but the Finder sees them, and sometimes you have to do some workarounds. Like, for example, I wanted to check for the password form field that had the obscure parameter, and yeah, it was visible all the time. Even though the user couldn't see the password, the Flutter sees it all the time. If your test fails before the code finishes executing, then maybe you should wrap your async part of your test with tester run async, and then that should work. Also, sometimes the debugger doesn't stop in your breakpoints. I'm not sure if this happens just in Android Studio or in VS Code as well, but one useful thing that I don't think it's that popular, you can actually use debugger from Dart developer and just paste this line in the line where you want the IDE to stop, and then it will surely stop. But remember to remove it later, because otherwise your test won't run. Also, you may encounter pending timer errors, and that means that you have either a running animation or, for example, if you are using snack bars, this can happen quite often. So you just need to pump for a given duration to make sure that it finishes. Also, make sure to close all your timers and controllers in the onDispose method. And if your app uses network images, yeah, also just the widget tests have problems with that. And for that, there is the network image mock test dependencies that you can add, and you just have to wrap your test with mock network images 4, and then it will start working. And also, if your JSON files are too complex, then it may be worthy to split them in smaller parts. And this will require some time investment from your side, but it will pay off, because you will be able to build your responses from smaller parts. So for example, if you have an e-commerce app and the orders response is super huge because the order object is big, then you can just have smaller JSONs that will have one product, two product, no product. Then you can have user data for logged in user, anonymous user, etc., and programmatically build the JSONs on your own. And there is just one more concept that I would like to very quickly tell you about. And this is basically running the full tree widget test on your production app. So we are using it in our project because our app depends on the content that is provided by the content team, which are not technical people. And sometimes they publish something in a wrong format, it's not displayed. And what we do in such tests, we run them on production, and we test if a given type of widget, so this is the difference, is actually displayed. And yeah, it's just for quickly checking the setup. So there are no many complicated tests. We just test for those things that were usually problematic. And for this, I added like a section of post of the day to the application. And I'm not interested in the content because it will change every day or dynamically. I just want to make sure that it's always there. And for that, you need to set up those tests in a different folder. So you will have to run them by specifying this folder. And yeah, running those tests is quite similar, but the difference is in here. So we are not actually mocking the API responses. We allow the app to make the calls, and for that you need the HTTP overrides global as null. And the problem with those tests is that they are more fragile because they make the actual API calls. So sometimes you have to make sure you pump a lot of frames, you wait because you are actually making the call. So sometimes it may fail even if it shouldn't. But in general, it works quite well as a quick check. So what I would like you to remember after this talk is that you can write integration like widget tests. They shouldn't replace normal tests. I think they're a nice addition, but always remember to also write your unit tests and write normal widget tests if a widget is complex enough on its own and doesn't interact with different screens or widgets. And also, it's very great if you want to mock various errors and make sure you are prepared for them, and that you can also run them on production and do some kind of health checks. And the setup is the worst. Afterwards, it's all fun and unicorns. And if you have any questions, I'm not sure if we have time, but I would like you to go to this QR code and rate my application. And there's also an open Q&A, so you can post your questions there. The Slido will be open till end of the month, so 3 days. And I will just answer them later. Okay.